This is a common need in any logic. In order to write certain code outside of a certain confined set, I'll sometimes need other features of Java. And in order to refer to those features of Java, in any Java program, AnyLogic just being one example, you need to actually tell Java, like, hey, I want to use this feature of you, this broad set of features. And that will allow it to kind of make the requisite information available about the names of those features, etc. So what you have to do, it's very simple, but you have to go here, this is in main, so you have to go to the appropriate class, so go access this thing, and then you need to go down to this area which is called Advanced Java, and you have to say this import thing. And basically, this basically says, I want to use an area of Java involving streams, okay? And that's what you do. You say import that. And you'll notice if you do that, I'm not saying you have to, but if you do this, just tons of things that, oh, I don't know why that came up in particular. There's tons of things that you can, oh gosh, there's all sorts of things here that's filling in J. There's all sorts of things that I can use out there. This is one of the virtues of running atop Java compared to, say, with NetLogo running across a more or less custom language. It's you have this unbelievably big universe of tools that are out there. If you want your model to access weather information, if you want your model to go over to a fancy NoSQL database, if you want to access information from smartphones on data collected in the past day, if you want to have your model call off to routines to do solving of fancy equations, there's huge, I mean, it's hard to overstate how many Java libraries there are for things. And this is just one example of the sort of all the types of things. This is just J, right, that I have access to me. And I only do this quite rarely in example models, but if I'm building a bigger model, it's not uncommon that I'll use one or two of these things in it. So you do import, and you say, I want to use these features of Java. And this star means just all of them there. Turns out within this stream, there's a whole bunch of different things that you can use, and you just say, I want to use all of them. So this is what I did.
There's a sidebar. I mean, does anybody other than Margin use C++ as its underlying?
Yes, they do. So I speak as someone who's written hundreds of thousands of lines in C++. Most of them in the late 80s, early 90s, and as a professional software developer, etc., and as a researcher. So the other major platform that does use C++ is Repast. Repast is a very popular agent-based modeling platform that has the virtue of being open source. And quite nice, and it is widely used. It has been widely used. Excuse me. So these days, I find a lot of people find it very difficult to get into Repast, partly because of C++. Partly because
as a novice, I can tell you, I agree.
yeah, partly because it's not declarative. You're constantly dealing with how you do things, and you don't have the ability to step back and reflect on what it is you're trying to capture. I mean, this you can quibble with AnyLogic, and I personally have compiled dozens and dozens and dozens of shortcomings of AnyLogic, and I could probably list hundreds if you locked me up in a room for 3 days. But there is something to be said for having a visual depiction of the model, and it's not just that it's easy to glance at and appreciate, and the aesthetics are nice. It actually depicts what you're trying to depict, and abstracts away from the how, abstracts away from the details of how these things are realized. The fact that you can say, please transition from here to here after exactly a certain amount of time, it takes care of the how. You can specify here, proceed according to this hazard rate, instead of needing to, in your code, loop over, have I transitioned yet? Have I transitioned yet? Flip the coin, have I transitioned yet? The fact that you could just say, transition from here to here with this hazard rate, that really enhances the ability to understand the model at a high level and share it. And unfortunately, Repast, it's moving in that direction, but it's still got some real encumbrances. Now, C++ is a language. C++ is a language that's much harder than Java, and it's much more dangerous than Java. By default, you have to, there's memory management issues where you have to manage your own memory, and just dealing with certain issues is that much messier, and the conceptual understanding required is that much higher. Whereas Java is a little bit easier to get to understand. Winchell and myself have had the experience of maintaining Repast code bases. And really, it's a big software engineering exercise. It turns into, for a non-trivial model, it turns into decent-sized software engineering. You're basically a software developer. And with any logic, I'm not going to deny that there are some aspects of, you'll want to have recourse to a software person occasionally, but it's not a big software engineering exercise. It's a very different feel to it. Winchell could share experiences if you were interested offline about this, but he has the experience maintaining Repast code base for a graduate student colleague, and basically Winchell is the software engineer for it. And this is a difficult thing because you go back and forth. I mean, you have to understand, I'm a software engineer by training, and I teach software engineering classes. I'm up to date with latest software engineering innovations, as is Winchell. But it's very distracting to go back and forth from my modeler hat to my software engineer hat, and vice versa within the course of a morning. Because, with Repast, I'm constantly thinking, how am I going to implement this? What's the structure going to be? Where am I going to declare this in terms of the code? Can I rearrange this code? Can I refactor it so it's cleaner in this way? Whereas with any logic, I tend to be more focused on what I'm characterizing. And I do get into the how sometimes if the model's really slow or if it's malfunctioning or something like that. But for the most part, I don't have to spend a large amount of my time thinking as a software engineer. And the things that I worry about, the things that I struggle with are more modeling issues than software engineering issues, where often the reverse is true with platforms with big C++. So I happen to have a big bias on this. I have loved C++ for much of my time with it, but I think it's a bad language to use for modeling with a capital B. And there's another reason for that. And ladies and gentlemen, we are heading into the world where the big motivation for Repast and for ModGen using C++, quite frankly, is performance. They want to eke the latest performance out. And the way they're trying to accomplish that is by getting close to the metal, as we say, to have a low-level language that will compile into efficient code so it can be run quickly. And that's old school. And these days, when people look for performance enhancements, where we're looking for performance enhancements with parallelization. And it was interesting. I was talking with Dr. Yan yesterday about a project that was putting things in the cloud. I think what you don't want to put in your cloud is the model definition. You want to make that accessible to lots of people. But what you do want to put into cloud is a lot of computation in many cases. But if it's not in the cloud, if it's in an organization like PHAC, you want to be able to run things in parallel, because that's where you're going to get the big performance speedups, not by keeping it low level so that you can have it run 20% faster. You're going to get the 10 times speed up by being able to run your model, your sensitivity analyses, your calibration runs, or what have you, in parallel across 10 different cores. That's where we're going. And hitching your cart to the C++ bandwagon, I think, is a strategic mistake. And so I would advise against it, and I think it's going to be a big encumbrance. Yes, Vivian.
Thinking again about I think we also have to appreciate when we're talking about multidisciplinary work, the is
Yeah.
what modeling essentially is.
Yeah.
In order for various members of the team to really be able to bring their
Yes.
expertise to bear,
Exactly.
if it's just the member or two of the team, or they're
Yeah.
grad students who are software engineers, and their modeling choices will be made that may not be
Exactly.
as academically sound, which will not access the full
Oh, yeah.
expertise of the group,
Precisely.
and it will also not be able to be peer reviewed and validated. Or people won't be able to see into the model.
Yeah.
Yeah, and
The-
I mean, questions about reproducibility, all those kind of things are,
That's right.
Yeah, these state charts and everything you pull up are
yeah,
really facilitate engagement of all parties. It's
yeah.
whereas if you're working with this Modgen, which sits on top of C++, you don't even see that. And even if you did, it wouldn't mean anything unless you're, like I've been trying to do, flog it and try to understand it. Whereas this, everybody engages. It's truly a wonderful thing.
That's right. I mean, I know this week has not been easy for you, and you might have felt like that person in Minnesota who asked, do people ever wig out at these things and just can't take it anymore? But just to let you know what you're avoiding. Here is a comparable model in Repast. Which you can look at. And so imagine trying to get this. I think Vivian made the most important points here. Imagine trying to get this peer reviewed. Imagine trying to know what's going on in this model. Pages after pages of code. How are you going to elicit understanding from your stakeholders that are going to tell you if this model's behavior is reasonable? How are you going to get them to look at this and say if your assumptions seem to them questionable? How are you going to ask them to develop confidence in a model they can't even understand? And in fact, your understanding as a investigator is limited by you having to talk to a professional programmer who is not a modeler, who is maintaining this code base. And this is just one file of about 75.
That's what poem looks like.
That's right.
But to me, this is the equivalent of, the scenario you're talking
Yeah.
about is the equivalent of, the kind of research that happened 25 years ago where MDs who had no training in statistics would go and design an experiment and then ask the biostatisticians,
Right.
to do that work off on the side.
Or with health economists later on.
Or with health economists later on.
Yeah.
And which is what we're trying to get past with health economists and trying to get the health economists and the modelers integrated into the work.
Yeah.
But as we have had to move away to have EPIs and biostatisticians integrated from the beginning of the research agendas, we've got to do the same. We've got to use platforms for modeling that enable that.
That's right. And I think also from the standpoint of even investigator confidence, I know this project was one where the investigator had no idea what was in that model, really. I mean, they thought they did. When we went and actually investigated what was truly enabled in it, what was disabled, it was very different from what they thought. In fact, there were lots of bugs in this, and they had papers writing on this stuff, and it was a real problem. It was a real problem because they had invested so much in this, hired programmers, had them do it, but they were so at arm's length from the reality of it, and the programmers were changing over time, that it just went off in a direction they didn't really understand what was going on. And so I know it's not easy, but this is a world apart from that in terms of its ability to communicate. And yes, you will want that computer science buddy, but at least you won't be stuck staring at a model and wondering what are the basic assumptions of this, right? There's a lot of people you could share it with and get feedback on, etc. Okay. Anyway, some comments. I welcome those.